This is Geometry Unit 12, Lesson 10, Circle Proofs. What we're going to be working on is proofs that deal with circles. So the following facts or theorems may be helpful in tonight's homeworks and the upcoming test. So let's just run through the theorems that we know about circles. What do we know about the radii of a circle? All radii of a circle are congruent. That one we use a lot. A radius or diameter and a tangent to a circle are. So if you have a radius of the circle and you have a tangent to the circle, what do we know about them? They are perpendicular. So that means if AB is tangent to circle O at point B, that means that OB, the radius, is perpendicular to the tangent line. OB is perpendicular to AB. So that's our first couple theorems. Another theorem, the arcs between two parallel chords are. Well, let's see, we have chord AB and chord CD that are parallel. So we're looking at arcs AD and BC. All right, since we proved this before, if the arcs between two parallel chords, the arcs are going to be congruent. So that means if you have a pair of parallel chords, then AB and CD are parallel, then arc AD will be congruent to arc BC. Now let's look at inscribed angles. Inscribed angles that intercept congruent arcs are. Okay, so for example, right here we have angle CBD and angle EAF. They intercept arcs CD and EF, and CD and EF are congruent. Well, what does that tell me? The angles that intercept them are also going to be congruent. So if arc CD and arc EF are congruent, the angles that intercept them are congruent. Angle CBD will be congruent to angle EAF. Because these arcs are congruent, these angles that intercept them are all congruent. Also, this is true as if inscribed angles that intercept the same arc. All right, so let's look at angle CBD and ADC right there. What arc do they intercept? Well, if we look at CBD, it actually intercepts arc CD. And angle CAD also intercepts arc CD. So if they're half the measure of the arc they intercept, aren't they going to be the same? Yeah, inscribed angles that intercept the same arc are congruent. So, again, if CD is being intercepted by two different angles, in this case we have angle CBD, let me do a different color here, that intercepts arc CD, but then we also have angle CAD that intercepts arc CD. They're intercepting the same arc, so they're congruent. So angle CBD is congruent to angle CAD because they intercept the same arc, CD. All right, and our last theorem is kind of a coda to the last theorem, or a corollary. An inscribed angle in a semicircle is A. Well, think about this. An inscribed angle is half the measure of the arc it intercepts. Well, if this is a semicircle right here, AB is a semicircle, how many degrees is that? It's 180. So if that's half, that means that an inscribed angle in a semicircle is 90 degrees, or a right angle. So since angle ACB, the endpoints here make the diameter of the circle, that is a semicircle, that means angle ABC is a right angle. So these theorems about circles are what you need to know to do the proofs tonight. They will be reasons in your proofs. So be looking for these different things in your proofs.